The Scrum Masters throughout the project in chronological order are Costa, Ben, Jack, Anthony, and Chris. The Scrum meetings were effective in relaying information such as what everyone or each department is working on, what obstacles are there, and for sharing ideas on how to improve our existing process and application. However, there was a noticeable lack of attendance during the later sprints, which we chose to remedy by instead writing update messages via Discord instead. Here is an example of what those update messages look like. There are a few things that we could improve on for our Scrum process. The pull request took too long to review, which halted developers from making further progress. The task and manpower allocation between front-end and back-end was unbalanced, and the Git workflow varied between members in the first few sprints. However, there are also quite a few things that we did well in. First of all, our communication was solid. We updated each other often, proposed and discussed ideas about our project quite frequently, and responses to messages or announcements were quick. The work culture was very enthusiastic and everyone was willing to help each other and learn new technical skills for the project. Problems such as the ones listed above were fixed quite swiftly. For example, one of our team members, Costa, noticed the Git problem quite early and wrote a comprehensive README file to address this, and everyone immediately read it and followed his conventions, resolving that issue pretty much immediately. We used a Discord channel to communicate within the team. There are many text channels to organize all of our conversations by topics, so it is easy to refer to. As said before, everyone was very quick in responding to questions and announcements. Meetings were held between members and within departments to ask technical questions, plan the next sprint, allocate tasks, and onboard new members. Every meeting was also documented in minutes, so people who missed it can refer to it or reread them if it was ever unclear. Overall, our communication was one of the strongest points during the entire process.
In gathering requirements for our road time trial web app, we elicited requirements directly from the customer, John, and indirectly from our tutor, Yang, throughout development. So the first stage involved identifying the requirements of the customer and stakeholders. This was achieved first through John Pittman's lecture presentation, where he outlined the overall objectives of the system. John also provided two products, which were currently in use by his team, which was the Best Bike Split website and the custom Excel spreadsheet. The majority of functional requirements could be implicitly formed by combining the feature sets of those two systems. Next, a development team or product owner would usually group these requirements into useful clusters. Fortunately, this was already done for us by our tutor Yang in the sprint user stories that she provided on GitHub. In the following weeks, some of the customer's initial requirements remained a bit unclear or infeasible within the given time frame. Particularly, the spreadsheet was quite confusing to begin with. And this required a negotiation phase with the customer, first via a Zoom Q&A, and then later by a Slack discussion forum, where we could ask both structured and unstructured interview questions. Another form of negotiation occurred through our proxy, Yang, who could critique our development progress and our system scope at the end of each sprint. And then finally, we needed to formally document all of these requirements. Fortunately, detailed requirements were directly provided by John, but we did modify this document over time to sort of reflect our meetings with Yang and also where our priorities were from sprint to sprint. So by gathering all these requirements early, we were able to avoid most major changes. That said, one major requirement that did need to change was dropped during the client negotiation phase. So in essence, we'd originally intended to enable the user to create separate bikes and then separate riders, and then you could combine them together to automatically calculate drag. This was a feature that was provided by the Best Bike Split website, but we found during our Q&A with John, he specified that he only needed to add manual CDA or drag from their wind tunnel experiments. So this basically required us to merge the bike and rider objects together to form a single object. And this meant significant changes to our backend and database design, as well as merging our bike and rider forms into one. But fortunately, this didn't have really any impact on the wider system. And it also meant, fortunately, that we didn't have to include additional parameters, like handlebar width or cyclist height, because they were no longer necessary to calculate drag coefficient.
We established a definition of done in the initial team meeting, which remained mostly unchanged throughout the course of the project. We selected 5 criteria for our definition of done, with each chosen to address a different aspect of the project in terms of quality, consistency, and functionality. The first criteria is that code passes automated unit tests in jest. Unit tests must be passed to ensure the code runs properly and to detect possible bugs in the software. This criteria aims to ensure the code is functional and runs without errors. Criteria 2 is that the code is peer-reviewed by at least 2 other relevant team members within their subteam. Front-end engineers will review front-end code. Code is primarily reviewed through pull requests on the shared GitHub repository. Each pull request must be reviewed before it is accepted, and allocations for team members to review can be made. This criteria aims to ensure all new code is of a high quality and reduces the need for cleaning code at a later date. Criteria 3 is that the code must meet the non-functional requirements, which has 3 sub-criteria being user interface is easy to use for users from non-technical backgrounds, underlying code is efficient and utilizes appropriate data structures and algorithms, and proprietary user data is securely stored on a database and encrypted if stored online. Each sub-criteria specifies qualities which should be present in the final product and which influence the user experience. An easy-to-use interface is important as our primary users will be athletes and coaches. Efficient code and appropriate data structures will reduce the processing time and allow for faster response times from the application. And protecting user data is an important cybersecurity requirement and will give confidence in the privacy of information uploaded by the users. Criteria 4 is that the code is correctly formatted using Prettier. This criteria aims to improve code readability and quality. Prettier is chosen to ensure consistency of code formatting between team members and to reduce the workload on managing formatting. Finally, criteria 5 is that the acceptance criteria are met. Each task had a set of acceptance criteria listed on the GitHub issue, which had to be marked off to complete the task, as can be seen on the figures below. This criteria ensures that the product will meet the functional requirements established. The initial meeting effectively established the definition of done, and apart from adding criteria 4 during sprint 1.2, the definition of done was working effectively, and so no major refinements were made. Criteria 3 could have been refined further, as the sub-criteria are not specific or measurable, which makes them subjective. However, this decision was not made.
Talking about the tools we use to build our application were, for frontend we use one of the most famous and industry-leading open source framework of JavaScript called React.js because we wanted to make a highly interactive and optimized single page web application. Plus, to make our application look more appealing and attractive, we added a Chucker UI, which is a styling library, and we used it because it was simple, modular, and accessible component library. And for data visualization, we use Highcharts because it comes with all of the tools we needed to create a reliable and secure data visualization. Now for backend, we are using the best combination in the market with React.js as a frontend is the combination of Node.js and Express.js because it is asynchronous in nature, so building real-time and data-intensive web application was very useful. Lastly, we decided to use Google Firebase as a NoSQL database for our application because data is stored as a JSON format and synchronized in real time to every connected clients. Talking about the technologies which we wanted to use in our project but we were not able to do was TypeScript because most of the group members were not familiar with TypeScript and had a really good knowledge and experience with JavaScript. And I believe that TypeScript could have helped our project in multiple ways because TypeScript is a superset of JavaScript, which means that it can provide us with multiple features such as interface, abstract classes, function overloading, and many other things as well. Lastly, we also needed a data visualization library to visualize the RacePower plant properly. So looking at the efficiency, dataset size, feature provided by these libraries, thus we picked Highcharts, which was a charting library purely written in JavaScript, which was offering an easy way of adding interactive charts to our website.
The team chose to use Jest as a JavaScript testing framework to test code, both on the client side, that is on React components, and on the server side code as well. We choose Jest because it is very fast, provides a good code and file coverage, and has a built-in mocking library. The team made great use of Jest during the early stages of development. However, as the project progressed, we gradually stopped using Jest and focused more on the implementation of the web application. The team opted to not perform test-driven development for two main reasons. Firstly, the team was convinced that it would make our GitHub repository too complex, since it would have both test code and implementation code. The team also deems that test-driven development is not adequate for this web application. This is because the team has engaged in a lot of code refactoring, particularly in the server-side scripts. Instead, we peer-reviewed our work by going through pull requests. The team ensured that the code to be merged is fully functional before merging into the main branch. The team is committed to delivering a bug-free product to the client. Hence, in the final stages of the product development, the team, particularly Costas, has found and resolved any lingering bugs that were still there. If we had any improvements that we would have done to the testing, the team would have definitely engaged into more rigid peer reviews before merging into the main, since we did have a significant number of bugs in the main towards the end of the product development.
Overall, our group made excellent progress over the course of the project, as we were able to complete all functionality expected from our client. However, there were several challenges that impeded our progress at times. Firstly, learning a new tech stack was an important skill. Since some team members had never used React or Chakra UI, our front-end components library, it was a slight learning curve at first to familiarize ourselves with these tools, which slowed down our completion of tasks. However, since our development team was willing to self-learn unfamiliar technologies, all members were able to contribute effectively to the project. Another challenge that impeded progress was understanding how to use Git for version control. Initially, we found inconsistencies in individual Git conventions, such as inconsistent naming of branches, merging unreviewed code, and a general lack of understanding of Git workflow. To mitigate this shortcoming, during Sprint 2, one teammate developed detailed instructions on our README file on a consistent Git workflow. Consequently, these instructions provided cohesion across the team and allowed more progress to be made in development, since we were spending less time resolving confusion regarding our Git workflow. If we could restart our project, one improvement we would make to our software process is to implement velocity points in our user stories. Since we did not use velocity points, it was difficult for us to measure how much work we actually completed sprint by sprint. Therefore, any incomplete tasks were moved to the next sprint, without gaining an understanding of overall team progress. If we calculated velocity points effectively per sprint, we could find a suitable number of points to complete for each sprint, thus ensuring we would make consistent progress with a manageable backlog of tasks allocated per sprint. Additionally, it would have been beneficial to decide upon a standardized Git workflow at the beginning of the project, rather than implement it partway through. In this way, we would have been more confident with processes such as branch creation, rebasing and squashing our Git commits, and merging pull requests from the commencement of the project.
During the development process, I created an extensive README file in our GitHub repository acting as our core documentation. This document outlines project installation, Git fundamentals, our established workflow, style conventions, Git do's and don'ts, and guidelines on commenting and documentation. This resource is intended to be read by two groups. The first group is current developers. Although our team had a relatively smooth development process, our members often needed confirmation of steps in our workflow or conventions. This documentation ensured that developers had a detailed guideline to follow when encountering such issues. The second group is future maintainers. In the case that our current team is not available to assist for next, this documentation is in place to ensure smooth development. Hence, we include sections on project installation and setup among the other sections. We did not follow a specific procedure or standard when maintaining our documentation. However, if developers encountered an impediment or confusion during development, we ensured to make note of it in our documentation. For instance, during development, one team member needed clarification about variable declarations in JavaScript. Hence, in the case that this was a widespread confusion, we included a section on JavaScript conventions. This was important as it grew our repository of information, acting as a source developers could refer back to if needed. Throughout development, we ensured that our documentation was organized and in order of most importance to least. At the beginning of our documentation, we had a table of contents, providing quick access to each section for readers. Each documentation section was clearly labeled with headings and subheadings, and thoroughly detailed to ensure no further confusion. This worked effectively in driving the development of our project. Although our documentation extensively details developer-related information, it would be important to include additional information on project setup, requirement, and overall vision. One way to think about it is like a game of whispers. As the project is transferred between different generations of teams, the original vision is inevitably lost in translation. Hence, this aspect of the project should be well documented, ensuring that future maintainers can refer back to the original thought process and philosophies.
One factor that led to the creation of better code was the use of Git version control. This allowed the team to collaborate with each other easily and efficiently, despite working on different features via the use of branches. The use of Git was facilitated by GitHub, which also has a feature called GitHub Issues for project management, which we use to a great extent. This allowed us to list tasks, describe them, and track their progress all in one location. The team would create a new branch for each issue, allowing us to separate all the work in progress code from the code in the main branch. When the issue was finished, a pull request would be opened so that other team members could easily review the code for any mistakes or bugs, thus reducing the likelihood of defects making its way into our final product. Our team also implemented a protocol to improve the quality of our code by ensuring that any pull request must be reviewed by two members from the same team, whether it be front-end or back-end. This meant that reviews were performed by multiple individuals who were knowledgeable with the work at hand, and thus able to identify mistakes that may otherwise go unnoticed. The team utilized pair programming to a large extent, as we found it was a great way to train and share knowledge by pairing up inexperienced members with a more proficient member of the team. Additionally, a study from the University of Utah found that code developed during pair programming had 15% less defects than code that was developed without. Another factor that led to improved code quality was the creation and usage of documentation. This documentation was placed in a commonly frequented location by all members of the team, our GitHub repository. It answered a lot of frequently asked questions, provided a description of our Git workflow, and listed some common JavaScript conventions that the team used. We found that this was an easy way to share some basic knowledge between members of the team, as it was easily accessible and highly relevant to the task at hand. Given the opportunity, we would like to try and find out the effectiveness of different methods we use to improve the quality of our code, such as the use of pull requests, pair programming, and documentation, but also static analysis tools such as linting. To do this, we would need data from analyzing commits and pull requests made over different periods of time. This is because the different methods we use were introduced at different periods of time, so it should be possible to analyze the commits and pull requests during this time and determine the number of defects present, and whether the use of these methods were effective or not. This would allow us to determine which methods were most effective for us in improving the quality of our code, but also find any defects that were not caught by the use of these methods, which will allow us to educate and reduce their occurrence in the future. Our hypothesis is that static code analysis will only reduce the number of minor issues in our code, whilst manual code review is still required to catch major issues that will significantly affect the end user.
Task allocation was a major strength in our group process. For example, we decided early on to split teams into two subteams for development. We had a front-end team that worked primarily on designing and implementing the UI, and a back-end team working on calculating the RacePower plant and implementing the routes. Another strength was that we had weekly Discord meetings for the Scrum Master to evaluate the current state of the project and redistribute tasks to team members. We also had weekly Discord stand-ups for team members to state what they had worked on, what they are currently working on, as well as any issues they are having. The benefit of these processes was that we could work on multiple tasks at the same time while remaining very organized. We had good branch management throughout our project by assigning each issue its own branch that was named the same as the issue. This made it easier to keep track of issue progress and allowed team members to work on the same issue because it was easy to resolve any code conflicts. Finally, we made a really good choice to use Discord as our main form of communication. It served as a hub for anything related to the project and allowed us to discuss and plan tasks, organize meetings and deadlines, and resolve any issues with the code. We accomplished this by having many Discord channels for designated purposes. The benefit of these processes was that we minimized wasted time and reduced the amount of duplicated work. Overall, the benefit of these processes allowed us to complete the project by the deadline. We did have some weaknesses in our group process though. The first is that pull requests often took a long time to be reviewed and merged because there were always the same people assigned to them, and they sometimes got busy. We also sometimes had people working on the same task without knowing, and then we ended up with duplicated code. This happened many times in our front and back end teams, and was resolved through communication, but time was wasted. If we were to do this again, we would create a rotating roster of people that are assigned to pull requests each week. We would then create a Discord channel specifically for people updating the team of tasks they are working on. Lastly, we had a lot of GitHub issues and pull requests that had very little information or detail. This often led to further meetings being required so that people assigned to them understood the requirements. This also happened with pull requests and led to delays in merges. We would fix this problem by ensuring that detailed descriptions on GitHub are made mandatory by the Scrum Masters and made to be one of our non-functional requirements.